shouldn't change the solution. Okay. Let me just share the screen with you. Okay. Okay, getting the most expensive product is similar to the one where we found the top grade. Okay, but here we are talking about most expensive. Okay, but the idea is the same. Okay, so of course, but this was meant to be an exercise for you guys, so uh, you can like practice more. Okay. Okay. Now, when it comes to ordering the products by price, okay, any attempts here? Okay, who solved this one?
I did it, yeah.
Yeah. Okay. Let's see what you did.
Give me a second. By price, right?
Yeah. So which what we mean here by value actually.
Okay, let me share the.
Yeah. So as you can see here, um, we are able to do this by using a very quick function called order by. Okay. So order by is a function that's, as we said yesterday, it's okay to use built-in function. Okay. One of the help functions that we can use. And this one needs you to tell the function, okay, what is the criteria of the ordering here? So you need to say that I want to order by the value. Now, why it looks like this, we will talk in very much detail about it. Okay, but the idea was to find the solution. Okay, like I didn't want you to think more than I want you to search for it. Okay, so finding the solution should be available in your first hit if you are searching Google, and I think you can find it right away in multiple websites. Okay, but again, Willie, here you are finding and uh, printing. Okay, like you shouldn't do two things in the function. Okay, so this
Yeah, you
function,
are right.
yeah, this function should only order. Okay, it shouldn't order and print because sometimes you just want to order, you don't want to print. Okay, but it will still do the printing even if you don't want to because you just mixed them. Okay.
Okay.
You don't need to call display products, so you can order them, and like the caller of this function, okay, the caller of this function can um, like call the print one. Okay, but this one can return. Yeah, so let this one return the order dictionary. Okay, and whomever using this function can maybe print, or maybe they don't want to print, maybe they want to, let's say, save it somewhere.
I
Okay,
can do that. Okay.
so yeah, so the job of this function is just to return an order dictionary by value, of course.
Okay. Key value.
Yeah. As okay, so
Well,
the
in this.
thing is, yeah, the thing is about about Lambda and about the link function that you wrote,
Yeah.
you are using var, so the type is I ordered enumerable. Okay, so
Oh, okay.
you need to return this same thing. Yeah, and like you need to return the same thing you have in the var. Okay, just see what's the return. Yeah. Okay, so
Yeah.
now it's returning the same thing.
Yeah, but I mean, I need to improve it because I want to return uh, a dictionary
Yeah. So
because that.
you can like the problem here. We will talk about this soon, probably today. The problem here is dictionaries are not very good when it comes to ordering. Okay,
Oh, okay,
probably
yeah, got
because dictionary uses hashing to place items inside
it.
the dictionary. So there's no guarantee where the items are going to be if you converted this back to dictionary. So like but at the end of like before the semicolon in line 77, so in line 77 before you end the line, yeah, yeah, here you can say dot to dictionary. So you can convert it back to dictionary. And of course, the dictionary needs to know who is the key and who's the value. Okay. Now the problem, like this, most of the time will result in a correct solution, but it's not guaranteed to be correct because dictionaries use hashing. Yeah. Well, the to dictionary it will need like to know key, where's the key, who is the key, and who's the value. You don't need it now. Okay, but there's a function called
Okay,
dot to dictionary if you want to convert it to dictionary. But
okay,
yeah, but
I can.
dictionaries, yeah, the thing about dictionaries, maybe yeah, you may enter product number one, number two, number three, but inside the dictionary, you will find product number three before product number two because the way they are placed inside the dictionary, you can't control that. Okay, they are placed randomly in random places. Now you can access them, yes, but placing them depends on the hashing of the key. Okay, we will talk about hashing,
What is
but
the hash table?
uh, well, no, well, hash table is something similar, but I'm not saying hash table exactly. Okay, but it's similar to hash table. Okay, we will talk today about hash sets. Okay, and we will talk about hashing. Then we can understand it like in a better way. But I want you to know that the ordering in a dictionary is not a guaranteed thing. Like you can't guarantee that if I inserted them in this order, then they will be placed in this order inside. It's not like a list. Like a list is ordered, okay? So when you enter item number one, then two, then three, you will find them in the same order. But when it comes to hashing, this is not guaranteed. Okay, this is a little bit of an advanced thing, but like we need to go over it anyway. Okay, what about the next question? So we want a function to create another dictionary for all products sharing the same price. Okay, where the key is the price and the value is a list of products, okay, that have this price. Okay, anyone solve this question?
I did.
Uh, who?
Right.
Yep. Okay, can you share your solution with us? Okay, So they created a new dictionary for the result, obviously. So you need to return this type of dictionary. Okay, so it's double and it lists and the value is a list of string.
Yeah.
So all what you need to do is to go over the products one by one.
Yeah.
Okay. Okay, and see the price of each product. Okay. Now, if this price is already in the result, then what should you do?
Add in the list.
Yeah. So, for example, you are going through the products one by one. Okay. Now, you found, okay, the first product is the price of the first product is 20. Okay. So, let's go to the result. Do we have key 20? Like, do we have the price 20 anywhere? So, if it's not there, you need to add it and you need to create a list, okay, for all the products that cost $20. Okay, and put the first product in it. Now, after a few products, you also found a product that also costs $20. Now, can you duplicate the key of 20? We can't duplicate the key of 20, right?
Yeah.
Okay. So what should I do? I already have a key 20 in the result. Okay. And the value is a list of all items that cost $20, right?
Yeah.
Okay. So what should I do? I should add this new product that also costs 20 to the list of products that cost $20. Okay. So you will notice that Suley has in line 110, if the new product contains key, if the price is already there, then okay, add it to the list of this price. Otherwise, okay, this is a price I see for the first time. So for example, suppose that you just saw a product that costs $100 and you didn't see any product that cost $100 before. So you need to create a new list for this one and add it to the result dictionary.
Yeah.
Okay, and that's it. Like it's like once you think about how would I do that in real life, not in code. Okay, all what is left is to translate your thoughts into code. Like it's the whole story, and eventually you return the product. Okay, the new dictionary.
Yeah.
Okay, so that's exactly the whole solution. Okay, thank you very much, Sudhir.
Thank you.
So, any question about this one, this solution? So, if you understood the question right and you know what do we want, okay, it's very just solve it on a paper. Okay, you need to solve it on a paper actually. Don't never start coding right away. Okay, you need to solve it on a paper with a pencil. Okay, that's what I do. If I saw the price, then I already have the key. Okay, add it to the value. If I don't have this price, then I don't have this key. Okay, add a new value to the dictionary. Okay, and that's it. Do you want to write this code? Or was it clear enough? Okay, let's write it very quickly. Okay, so ordering is just one line of code, like dictionary.order. Okay, that's it. Okay, let's remove those. Okay, so the function that we are talking about is okay, public static. So for the word static, it's something that we are just writing now. Okay, there will be a time where we explain everything about static, but please just keep writing it now and don't worry about it. Okay, so this one will return a new dictionary, okay, which is like first the price, okay, the shared price between multiple items, and a list of those items that cost, for example, this price. Okay, let's call this products by price. Okay, and it takes the original dictionary that we have, which was string and double. This one, let's call it products. Okay, we have the result. So it's from what we want to return, obviously. So I want to return this thing, so I create my result from this time. Okay. Okay, what should I do now? I will go over the products one by one. For each product in products. Okay, for each one of them. Okay, now I found that the first product costs $20. Okay, so I look into my result. Do I have this $20 group? Okay, if I do, so if my result dot contains key, okay, of this product dot value, value means here the price. If I have a group for this price already, okay, so what should I do? I need to add a list of this price. Okay, so result product dot key dot oh sorry, dot value should be
Add
yeah, add. Okay, so we are adding the product dot, yeah, this is getting a little bit confusing. Let's add here. Okay, once you have it on paper, it should look extremely easy, but I'm just trying to. It's the key of the result dictionary. Okay. Okay, product dot key is the name of the product. Okay, which is a string. Now, else if I don't have, like I found like the product dot value is $20 and I don't have it in my result. Like I don't have a group for the products that cost $20. So what should I do? So result dot add. Okay, here I need to add what this price. Okay, the product dot value. Okay, which is $20, $70, whatever, and I want to add a new list, okay, of string to put all the products that cost this value. Okay, what is the first item in this string, in this list?
Product.
Okay, I can put the item or the product that I'm just checking. Okay, product dot key. Okay, and here return result. Okay. Now it's all about just writing it on paper. Okay. And examining, okay, what should I add to what? And then eventually it will make sense just when you follow it like step by step. Okay. It's much easier when you have it written in front of you and you are just translating your thoughts to code. Okay. You don't have to write it in mind while you are thinking about everything. Okay. So the whole idea is just to organize your thoughts, convert them to code. Okay. But when it comes, there's no complicated algorithm here. Okay. Any question? Okay. So let's move to something somehow similar to dictionaries, and we will talk why they are similar, but it's a different concept, and it's called the hash set. So a set from math, okay, like when you say I have a set of prime numbers, I have a set of like anything, set of names of something. So it's a group, it's something. Imagine it as a list, but under extremely like under a very extreme condition that no two items should be equal to each other inside the hash set. Okay. Well, actually, it's not only the hash set, any set, okay, doesn't accept duplicate items. Okay. So you can create a hash set of integers. Okay. For example, let's call it H is, let's call it numbers equals new hash set of integers. Okay. So imagine it for now, imagine it as a list. So you can add numbers, okay? Like you can add 5 numbers dot add, you can add 6, okay? Now the thing is, if you try to add another 5, okay, it won't be added. And it doesn't matter how many 5s you add, okay? There will always be 1 5 only. Now this one is not like a dictionary. You will throw an exception if the key is repeated. Okay. Of course, here in Hasid, there's no key value. There's only value. Okay. We don't have pairs in here. But it won't throw an exception. If you looked at the add function, so the add function itself, if you can notice, is returning a Boolean. Okay. The add function itself is returning a Boolean. That means if the number is added, it will return true. If the number is not added because it's already there, it will return what? False. Okay, and that's how the add function works. So first, let's write a function to print a hash set. Let's say of integers. Okay, so let's write this one. And let's send the numbers one to it and see how many 5s we will find there.
Yeah, just two numbers.
Yeah. So as Hans said, you will only find 5 and 6. So it's pretty simple to type or to print a hash set. So of course, I'm printing, I'm not returning anything from this function. Okay, I just wanted to do its job and finish, so it's void. Print hash set. Okay, it takes hash set of integers. It's called HS. Okay, and for each item, for each var item in HS, okay, what should I do? Just console.writeLine the item. Okay, extremely easy. Okay, just a loop and writing. Okay, let's try to call this one. So print hash set and send the numbers to it. Okay, so I'm calling it in my main function. Okay, again, the main function is where your code is supposed to start working. Okay, and it will do it line by line or statement by statement. So if you didn't call this function anywhere in the main function, like this one was never called from the main function anywhere, okay, or something that was called in the main function, okay, then it won't be executed. Okay, so you will notice that I have 5 and 6. Okay, and it doesn't matter how many 5s I add, it's still 1 5 only. And this is the concept of a set in math, okay? That it's a list, okay? But it doesn't accept duplicates. And this is extremely important in so many cases. Like in so many cases, you need to make sure that I don't have more than one copy of the same item, regardless, like, is it an integer, is it a string, probably an object, okay? And how they get compared, this is a different story, okay? And what's the meaning of the word hash? This is also a different story, but think about hash set as, for now, something similar to a set, okay? Now, the concept of hashing is still something we didn't talk about. Okay, so just like all other data structures in C#, you have those popular functions. So you have numbers dot, we saw the add, okay, remove, it will remove it, okay. Now, of course, it needs to find it. Like if it's not there, then it will return false as well. Okay, so now you can remove 5, but you can't remove 7 because 7 is not there. Clear, it will delete all the items, so the hash set will be totally empty after the clear. Count is also very important to know how many items you have inside the hash set. Okay, contains, this is also very important to know if you already have, like, do I already have a 5, okay, or like 6 or not. Okay, so those are like you will see them start, like those are the like most common ones, okay, and the rest are like almost most of them are link functions, but those are the main functions of a hash set. Okay, we mostly care about add, remove. We also talk about count to know how many items are there. Okay, so if we called remove 5, okay, what should happen now if I print it again? How many items we're
Only
going to
6.
find?
Only 1.
Yeah, you will only find 6. Although I added 2 5s, but yeah. So this is the first print. This is the second print. And you will find only one number. Okay. Okay, so hash set for now is a collection of items that doesn't accept duplicated items. Okay, now we need to find ways to like get advantage of this property in HashSet. So okay, so I want to write a function to check if a list, okay, let's say a list of integers has all unique items. So I have a list of integers, okay? It's not a hash set, it's just a list. And I want to know if all the items in the list are unique or not using a hash set. So let's think about it and let's then try to write the function itself.
Yeah, I'm done.
Okay. So let's wait for another solution. Okay,
I'm
anyone
done
else?
too.
Okay, so
I finish it.
yeah, Willie also. Okay, so let's see what Sari has. Okay, let me stop sharing. Okay, so check for duplicates. This is a list. You created a hash set for each one. Yeah. So what Sarah did here, she put all the items of the list inside the hash set, and then she compared the count. So if the list is already like unique, all the items are unique, okay, then it should equal to the length or the count of the hash set. Okay. Otherwise, suppose that the list is 10 items. Okay. One of them is duplicated. So the hash set that results from this list should be only 9 items, right? Because one of them is repeated. So now the length of the list is 10, while the length of the hash set is what? Is 9. Okay. That means the list wasn't all unique in the first place. Okay. That's the whole story. So wait, if new hash set dot count not equals, well, actually, that's the opposite. Like if they are not equals to each other, okay, not equal to each other, you should return false. Otherwise, return true. So just invert the false and true here. Okay. Yeah. So yeah. So now it's correct. Okay. So if they are the same length, that means the list was totally unique. Okay, thank you very much, Sire. So that's the solution. Anyone of you guys has another idea, or is this the same thing you use?
I use another one.
Yeah, let's see your idea, Sulen. Okay.
Use
So Sulen
I
here
can-
is trying them one by one. So what Sulen is doing, he is trying to find out if the list is not unique while he is adding the list to the hash set. So for example, suppose the list is 1,000,000 items, okay, and the third or second one is duplicated. So Sule is thinking, okay, why would I continue to the end if I just found out that it's not unique? So what is he doing? He's trying to add the items of the list one by one, okay, to the hash set. If any one of them failed, that means the item is already there. That means the
Return
like
false.
yeah, that it means it will return false. Yeah, so you don't need this one of result equals true. Like you can like result is already true. Once it becomes false, you can return the function right away. Like you don't need to return to wait for the for each to finish. So see the else. Yeah, inside the else, like, oh yeah, so yeah, sorry, I didn't notice. You had the return false, but you don't need that return equals true every time. So you can change the if. So the if not like if this operation equals false, no, leave it. That's the operation. But let's check if this one equals false. So if check num dot add, like inside the if equals false. Okay, inside the if, okay, put your
If.
cursor, yeah, equals false. Okay, now what should we do if it's false?
Return.
Yeah, let's return false. Yeah, and you don't need the else
Oh,
else result will remain true, right?
yeah.
It will remain true. Why do you need to set it true every time? Now, if you found any duplicate at any point, Sule will just return false right away. This this solution is better because it doesn't wait to finish the whole thing if there is a duplicate. It will finish right away. Imagine this is a very big list and you just found a duplicate in the middle. Do you need to continue? You don't. Okay, so this one is faster than the previous solution. Okay, although both of them are good, but in the worst case, like imagine like the worst case is the list is all unique, so you need to check all the list. Okay, in the worst case, they perform the same. Okay, because you need to check the whole list if it's all unique. Okay, in the best case, imagine the first number or the first item in the list is duplicate. Sule's code will exit right away. Okay, it won't continue. Okay, so this is one solution using the add functionality. So we can use the add functionality right away. If the add returned false, that means the item is there and we can just finish. Okay, like this list is not all unique. Thank you very much, Sule. So let's write it down. So we can use something like first, like Sari's solution. This one will return Boolean. Okay, so all unique list. Okay, and this one will take a list of integers and it will see if it's all unique or not. Okay, so we can create a hash set and put the list in it right away. So we can send the list in the constructor of the hash set. So you don't need the for each. Okay. Now, when you create the hash set of this way, okay, like this way, it will take the list and will add all the list to the hash set right away. You don't need the for. Okay. So this is one of the like advantages of using a hash set. You can send a list directly to it. Okay. You can send, I guess, any kind of collection. Okay, considering of course it's like the same type and like They are like from the same family. Okay, like you can't add a dictionary here or dictionary of strings, and okay, they should be somehow the same. Okay, now I have the hash set. I created it from the list. Okay, I can do something like this. Okay, so I want to return if the hash set dot count equals. So this is a condition. Okay, 2 equals means a condition. Okay, not I'm not assigning here. You can't assign equals anyway. It's only get. So I want to check if the count of the hash set equals to the count of the list. Okay, and return it. So this will either return, if they are the same, it will return true. If they are not, it will return false. Okay,
I have a question.
sure.
So I always use the, what is this, parentheses right after count, but it seems like I don't need them.
Yeah,
Is it
well,
because I
here,
don't
this is,
put-
as we said, this is a property.
Mm.
So it's part of the class hash set, and this is a function. But they result, but they result
This
in the
is
same
same.
thing.
Okay,
Okay, so you
thank
can use either one.
Okay.
Okay. Now, let's write the version 2 of this function. Okay, so it's the like another version. So I can create a hash set. Okay, and for each, of course, I need to create an empty one. In this is today's solution. So for each bar item in the list, okay, I want to try to add it to what? To the hash set. So if adding this number to the hash set, okay, results in false, sorry, if adding this item to the hash set results in false, okay, so we can say if not, what should I do here? Like that means the item is already there. That means the list is not unique. Otherwise, if I finish the for each and this false wasn't returned anywhere, that means it's all unique. Okay. So you don't need actually to create a variable called result. You can just like, you are not using it. Okay. You just want to return, and that should be enough. Okay. So both of them, but it's very important to know what are the differences between the both of the solutions, and what could be the speed of both of them in different cases. So if the list is unique, which one of those is faster? If the list is unique, they are the same speed. Both of them will scan the array to the end. Now, if the list is not unique, the second one is definitely faster because it may find from the first item, oh, it's not unique, from the second item, okay? And it will exit. While this one will add, like, it could be like a million items hash set. It will add all of it, okay, until it can compare the lengths. Okay, and that's the whole story. Okay, any question? Okay, what about something a little bit similar? So if I want to know if a string has all unique characters using a hash set. Okay. Let's think about this one. It's actually the same idea. Like you can solve it using the version number 1 of our solution.
Yeah, the same.
Okay, so it can be solved same way. So you can do something like let's write it here. This takes a string. Okay. And what should be written? First, let's put it in a hash set of characters. Calls new hash set of characters and takes that string. Okay. And just return if the hash set dot count equals to the string dot length. Okay, so the constructor of the hash set can take a string, considering that the string is an array or a collection of characters. Okay, and like if you send the word apple, for example, okay, the hash set will add the A, then the P, then it will try to add the next P, but it won't work. Okay, so the word will be, for example, the str will be apple, while the hash set will be APL. So the length of this one is 5, while the length of this one is 4. That means the string in the first place wasn't unique. The characters weren't unique inside the string. Okay? But if you send this one, it will result in this one, same length. That means the string you sent has all unique characters. Okay? And that's how it works. Just comparing the lengths. Once you get the idea, it will be very easy to work with hash sets. Okay. Now, if there any reason some of you guys aren't attending the lab, like, do you think you are not getting enough from the lab, or like in class, that wasn't an issue because you can't leave class when we used to go to the class, like you need to attend everything. But now with all this online, like also unfortunately I'm sensing that this kind of every day, like I can't attend, I have something, I need to go somewhere, okay, someone will record it, and uh, like this class is not intended to be remote class. Okay, like we need to work with each other. Now if you are rewatching this, you can just skip every time I wait and see the solution. You can try to not try anything. Okay, so like starting from next week, please, if you have something urgent or you are not able to attend, it's, I know, it's what it is. Like this is life. Okay, like if you are missing work, no one will record your work for you, or I know you can't take it back. Like there are consequences for, I know, being not able to attend something. Okay, because I'm feeling that because you can see the recording again, this is it makes much easier to skip classes. And Zach also is telling me that around 12 people only attending, so that means we have 7 8 not attending, or maybe less, maybe 5 6. But anyways, like if you have any suggestions how we can improve the lab, that would be nice. Sometimes there are new things that we teach in the lab, okay, and they are also required. So you are missing like new material if you skip lab. Okay, so please don't like we had to treat each other like school here, like high school, where take attendance, and This is not something we want, right? Like we are here to learn. It's very quick thing, few months, and you should be ready. Okay, and you are missing like an hour and a half of exercising of someone who's able to help. And of course, because it's remote, like we can't really do anything about it. But um, like we can start doing anything about it. Like we can start taking attendance or so. If there's a reason why you are not attending, please let us know. We can discuss it. We can try to make the lab more engaging, maybe, and try to improve it. Okay, if you just don't want to attend, this is against the rules here. Okay, like you can't just skip labs and classes. Okay, for for whatever reason you have. Okay, because like you are eventually, we will put, I don't know, our stamp or signature on your certificate. Okay, so like you will represent this place. Like if you are not ready to be able to work, like we are proud of most of our students. Okay, but we need to keep it this way. Okay, like I know, unfortunately, some people are here for the certificate for uh, like different reasons, but uh, this may be good for you, but it's not good for us. Okay, so like just going from here like without being able to do any programming work, without almost learning anything, slacking every day you have an excuse or not attending the lab at all. Okay, so please, okay, please keep attending. Okay, and do, like let's not go into taking attendance, losing grades, failing the whole course because you are not attending. Okay, we really don't want to be there. You almost like you are halfway through and even more now. The internship is 2 months, so you're almost there. Okay, let's keep it this way, and you are doing great. So let's just let's just keep working hard. Okay, just like before.
Yes, Mohammed.
Yeah,
I have a suggestion for a lab.
sure.
So I would like to have in the same page with the class and the lab. I mean, if we're talking about hashtag today,
Hmm.
for me it would be beautiful if we get the same topic in the lab. But the
Yeah,
issue is that if we study for, imagine yesterday. Well, yesterday was we talking about um,
so today it will be
dictionary.
about dictionaries.
Yeah, and
Yeah,
then but in the lab we we work with the list. So
right.
sometimes I'm working with your assignment or with your class, the current day class, but in the lab I'm working with another kind of piece of
Yeah.
information. So
Yeah, the
it
thing
would be
about
beautiful.
programming, yeah, it's all connected to each other. So
Yeah, maybe if we can see this option, I don't know if it's possible.
yeah. So the thing is, for example, the problem that happens is we take hash sets today. If you took everything about hash sets today, you will feel that in 2 3 days you almost forgot like most of it. And I noticed that like since we have some experience now in this program, particular one. So the idea is, for example, you study hash sets now, you understand them now, and then in 2 days the lab will be on hash sets, or maybe tomorrow. So it can be like an extra reminder. Like your mind can't absorb like 5 6 hours of the same thing. You will feel that like, okay, I'm done with this topic. But like if you are able to work on the same topic after 2 days, after 3 days, like now, for example, after a month, we may talk about a very quick hash set or very quick string of like algorithm or something. So we can remain in like in the whole mood of those things. Like otherwise we will forget about them.
No, yeah, I know, but my suggestion is imagine this case. We work on today with HASEC, right?
Yeah,
So maybe in the lab we can work with HASEC, but we can solve so many problems that we need to use another like list, but we need to use both of them. So using HASET and list, or using HASET and dictionary, or using, but not only focus in one different, complete different topic. Because
yeah. The thing is, if we did that, like for example, now what happens is most students understand, for example, Hasid understand 70%, 80%. Many students, they feel that they need to go home. Okay, I need to redo this question myself, or maybe I need to read a little bit. And by the end of the day, they will feel, oh, now I understand Hasid's more. Then tomorrow, when it's time, the problem is like lab is you are supposed to work in the lab. Now, if you didn't understand the class of Harsets totally, and I give you a lab right away without giving you a chance to work with Harsets, review them, maybe read a little bit about them, see a video, okay? You will feel, oh, I can't do this exercise. I just took this thing and I didn't get the chance to study it myself. So we usually give this chance to study it yourself, and maybe like the day next or after 2 days, it will be good for you because you will be starting to forget about hash sets anyway. So the lab will keep like it will totally like make you like even better with it after you get the chance to practice it yourself. Like I'm pretty sure now when I say there's a is there a question, there are many students who feel like maybe I didn't understand it, but okay, like once the class is done, I can maybe do it myself or try it, and I'm pretty sure I will be able to do it without even asking. Okay, so like in 2 days, if you took the lab, maybe you will be able to do it. But if you took it now, really, I know you are like you are a great student and you even have previous experience, but for most students is not as easy. Okay, they feel like I still need time. So if you give them a lab on the same thing right away, it will be really hard. But I really don't see if it's like 1 day or 2 day or 2 days between the lab and class. I don't see it as a very big like it's not like after a month or 2 months. Okay, like 1 day, 2 days, and you can see they are all similar to each other. Like we are using lists and strings over and over. We are using um, dictionaries. Like you keep using each one in the other. This is only the situation here, but tomorrow in like tomorrow with the website development and everything, the lab will be multiple days. So the lab will be start to become almost a separate thing. So we will learn how to build a website. Then in the lab, we have like a complete website that takes 2-3 days to build. Okay. That's, I don't want you to get to the habit of skipping labs because this program, the whole program is built on the assumption that you are attending labs. If you are not, then you are not really getting everything you are supposed to get from the whole program. Okay. You are skipping almost 30%. Okay, which is a terrible thing. Okay, so please um, keep attending the lab. Like I will try to make it as close as possible, but really this is only the case with first course. Like starting from next courses, they will be almost like interchangeable very much. Like you will feel that the lab is starting to get something like as something totally different. Okay, we will be talking about new materials while the lab is building a website. Okay, so hopefully you can like get the most of it. Okay, but and please keep going back home, trying to redo the questions. Be ready for the lab next day. Okay, the more ready you are, the more like knowledge you can gain from the lab. Otherwise, it doesn't matter how many questions I give you in the lab, you won't be able to solve them. Okay, now all of those problems are a little bit new because in class you don't have those issues. Okay, but we have to deal with them. I think we will get the opportunity to go back to class this year. I think it should be around maybe August. So I'm not sure if it's before or after the break of August, but we should be able to go back to class. Okay, and like it's very good because the next half of the program is mostly group projects. So we don't study lots of new materials. So maybe it's 1 hour only in class, and the rest is you as groups working together. Okay, so when you are close to each other, it's much easier than working online. And you can see everyone's performance and see the work. So hopefully we will be able to go back to class soon. Okay, and then of course no one can escape from the lab. Like we can see this right away. Okay, so this is how to get all unique characters from a string. Okay, and we have a little bit of a bigger question, but let's take 15 minutes break. Okay, we'll meet at 10:30. Okay, see you soon.
Gerald.
Okay, we're up again. So, speaking about more hash sets now. Okay, so okay, so let's go to this exercise. Okay, so we want to write a function to find the elements that appeared only once in the list of integers. So I have a list of integers, okay? Imagine the list is 5, 6, 2, 7, 8, 5, 7, okay? So the result should be what are the numbers that appeared only once, like not 3 times, not 4 times, okay? Not 2 times. So I have 6 appeared only once, I have 2, and I have 8. So that's going to be the result. And of course, like we are talking about hash sets, so we need to get advantage of hash sets. Okay. So again, please, once we finish, you have lots of questions, try to redo them yourself. Okay. Half of them is fine. Okay. Try to do everything and be prepared for the lab. Okay. Like I can't keep trying to push you more, but honestly, it's very important to keep reminding you that now we are going slowly, we are taking it easy. Soon it won't be like this. Soon we will work with databases, with big projects, with websites, with stuff that you didn't even study. Okay, so it will get more intense after this. So take advantage now that we are moving slowly and we are actually learning easy stuff. Okay, so that's the question. Let's try to think about it and then try to write the code.
We need to use hashes with this or no?
Yeah. Well, yeah, we can solve it without hashing, but let's try to use a hash set for that. Okay. If you have if you think you have some creative solution without hash set, okay, that would be fine, but it's just like an example of hash set. Okay, if it's not working with a hash set, you can use whatever you want.
Yeah, it's done.
Okay, Hans is talking.
Yes.
Okay, so um, Okay, let's wait just a few minutes more. Then we will see your solution. Okay, what if we say if you want to find a solution using a dictionary?
You mean create another
Yeah.
function? I finished this one. So
You already did it with the dictionary?
no, I finished with the first one. I'm going to use dictionary for the second one.
Okay, so before you start with the second one, let's see what Hans did. Okay.
Can you see?
Okay. So you are returning a hash set of items that appeared. Yeah, you can return hash set or a list. That's fine. So we didn't say what is the return type. So what are you doing here? For each item, okay, you are counting how many times in another for each.
Yeah, if it's the same with every element, it's going to, if it's greater than 1, it's going to remove that element from the list.
Yeah. So what Hans is doing here, actually, you are not using a hash set. You are just using a hash set for the result.
Yeah.
Okay, it's not part of the solution. Yeah. So what Hans did is he is taking a number, okay, from the list, okay, like number 1. Then what he's doing in another loop, in another for each, he's scanning all the list from beginning to end to see like, is this number repeated or not? Okay. Now, if it's not repeated, he will keep it in the list. Otherwise, he will remove it from varying element at I equals list dot element at j. Yeah, the thing about hash sets that they don't guarantee the order. So the second element in the list could be the third element in the hash set. Okay, you can't guarantee where are they placed inside the hash sets, just like a dictionary. Okay, so we can solve it without a hash set if we want two for loops. So if you want two for loops, you can easily solve it even without the need of hash sets. Okay.
I use one loop.
Yeah. Okay. Let's then go to Suley. Thank you, Willie. Let's go to Suley if you are using one loop. Okay. So hash set, you have the hash set, you have the list,
Yeah.
Result list. Okay.
If
Yeah. So
yeah,
so what's going on here? Let's first try to understand. So
I try.
Suley is taking the items one by one. If you can add it to a hash set, okay, then it's not in the hash set. Okay, so you can put it in the result. Otherwise, if you can't add it to the hash set, that's it's already there. Okay, he is taking it out of the result. Yeah, the problem here, what if you have a number that appeared 3 times?
Let's try if I have 3 ones. It's
You
okay.
need
It's
you
okay.
need console. Yeah, you need console.write or read key or something.
Yeah, it's okay. Because the first one is added in the hash set, and the second is checked is false, and the third is false. So it won't add into the new list in the result.
Okay, can you do the
Which return true?
no? Notice that
No.
result is a list. Result is not a
Result
hash
is
set.
list, not the hash set.
Yeah, the result is list. Okay, the result is not. So this is a correct solution. Okay, but like I know what Yushin is asking. Like Yushin, if you are only using a hash set, you are correct. If you are only using a hash set, the third number or any odd number will be placed again.
Yeah. Yeah.
But if you notice, like Suley is using a list for the result, not the hash set. Yeah, yeah, that's fine. I didn't see it first. I thought he's only using a hash set. But when you use a list again, okay. So can you do debugging? Suley, can you put a breakpoint in the function? No, not here, not here. In the function, okay. Can you like from the for each, from the beginning of the for each? Yeah, just put a breakpoint. Okay. So let's see why this solution is working. Okay. So first, Suley has another list for the result. Okay, so he will put the final answer in this list that's called result. Okay, this is a new one. So he is taking the items one by one. Okay, let's F10. Okay, yeah, he's taking the first item. What is the first number? Okay, can you stop on the number?
Number. The first number is 1.
Yeah, first one is okay. First 3 ones are only 1. Okay, let's go. Okay, so also yeah, F10. Or keep clicking this arrow. Yeah, keep clicking the same arrow you were clicking. Up, yeah, up. The arrows. This one. Yeah, next one. Okay, keep clicking this one. This is F10. Okay, so is the number 1 in the hash set? It's not in the hash set. The hash set is still empty. Okay, so if the number 1 is not in the hash set, if you can add it, okay, then This is the first time I see number 1. So I will add number 1 to the final result. Okay? Then let's go again. Oh, what happened?
What happened?
Okay, yeah. Now next number is what? Next number. Okay, keep pressing F10. Yeah, keep pressing this same arrow. Okay, again.
Where is the result?
Yeah. Okay, now what is this number?
1.
Yeah, it's 1. But I already have 1. That means 1 is not unique. Okay, so what should happen now? This one should be removed from the result, right?
Yeah.
Okay, so what happens? This one should go and be removed from the result. That means 1 is no longer part of my final result, which is the correct answer. Okay, now again, let's go, yeah. Yeah, again, the third item. Third item is also number 1. Yeah, keep pressing F10, F10. Yeah, until you reach the if. Okay, so now we have the third one. Okay, 1 is already in the hash set. So
yeah,
I don't have it. I will go and remove it. So here it's not like remove will not do anything because it's already removed, but you now sure that it will not be in what? In the final result.
Yeah.
Okay, now let's go to next one. What is the next number? Okay, next. Yeah, next. Yeah, so number now is 2. Okay, this is the first time I see 2. Okay, so it will be added to the hash set and also to what? To the AND. Okay, now if there is another 2 somewhere, the else will work and the 2 will be removed. And that's how it works. Okay.
Yeah. Next one is 5.
Yeah, so 5 is also the first time.
First time add. And the next 5.
Yeah. Now, because there is 5 already, you will notice that 5 is being removed from what? From
the result.
The result. Okay, thank you very much, Sulian. It will just continue. Okay, I will write this solution.
Yeah, okay.
Okay, yeah, just a second, please. Okay, yeah, so let's write this solution and try to explain it one more time. So we said this will return a list of integers. Sorry, am I sharing? Yeah, sorry. Okay, this will return a list of integers. Let's call it distinct items. Okay, it takes a list. Okay, and just returns the items that appeared only one time. Okay, so what should we do here? We have a hash set. Okay. Okay, the hash set is from type integer. Okay, and we need the hash set to be empty. We have also a list for the results. Okay, new list for the results. Okay, now I will go on the items one by one. And notice here that Sule only did one scan to the item. We will learn today what's the difference between going 1 time and 2 times, like 1 for loop or 2 for loops inside each other. Okay, what is the difference? Of course, there's a very big difference. Okay, so for each var item in, or let's call it number, in the list. Okay. Okay. So I will try adding this number to the hash set. Okay. I will try to add it. So if it's added, that means this is the first time I see this number. Okay. Otherwise, it wouldn't be added, right? Okay. So it's the first time I add this number. That means, okay, that's a good number because this is the first time I see it. Then add it to my result. Okay. Otherwise, if I failed to see this, if I failed to add this number to the hash set, that means this number, I've already seen this number before because I just failed to add it to the hash set, right? So what should I do? I need to remove it if it's already in the list. Okay. So remove will try, okay, oh, this number I've already seen it. So go and remove it from the result if it's still in the result. Okay. And that's the whole story. And eventually return the result. Okay. And that's just, it's as easy as this. Okay. Just think, like slowly think logically and write the code. Okay. Any question about how this code is working? Okay. Now, if you still like have like some doubt about it, just go and repeat it again, and it should work fine. Okay. Now, just talk very quickly about hashing. Okay. Of course, if you want to learn everything about hashing, there are many articles about it. It's a little bit of a theoretical thing, so we don't care too much about it, but we need to at least to know what is hashing. So hashing is in general converting a value to another value based on a hash function. So suppose that I have a hashing function, okay? And I will give you, for example, so the hashing function, okay, I will give you a function and, sorry, I will give you a number and the return, for example, let's say the hashing is 4 minus 4 multiplied by, or let's say, for example, 7 multiplied by x minus 1. Okay, so for example, this is the hashing function. Of course, hashing functions are very complicated, so they can generate as random values as possible. So if I told you, okay, what's the result of hashing 3? What's the result of, if I want to hash the number 3, depending on this hashing function? Hashing is just generating a new value from a previous value. So 7 multiplied by 3 minus 1, this will result in how
20.
much? 20. So very as usual, our mathematician. Okay. So what if I am hashing 4?
27.
Okay. So if I'm hashing 3, the result is 20. If I'm hashing 4, 7 multiplied by 4 minus 1, okay, that's 27. Okay, and that's it. So each number, each value has a hashing value. Now, hashing functions are usually made by extremely professional mathematicians, so they can generate as random numbers as possible. Now, if I told you like the hashing function always or most of the time is returning the same number, okay, this is a very bad hashing function. So hashing functions should return like mostly almost all the time different values. For each input, you have different output. Otherwise, like if the hashing function is always returning the same number, or in many cases, that's a terrible hash function. Okay, so what's like what's the idea of hashing? Why do we need this? Now imagine the hash set. The hash set imagined is as a big closet or a container. So when I say, for example, hash set dot add 6, okay, so number 6 will be added to this hash set, right? Which is something like a closet or a collection of places. So the compiler will ask itself, okay, where should I add 6? Is it in this place or this place or where? Okay, so it will add it depending on the hashing function of the hash set. So what will happen is the hash set will apply the hashing function on this item, on number 6, and depending on the value of the hashing function, the hashing result, like 20 or 27, it will find the right place for it. Okay, why this is important? Imagine that you want this item now. Okay, now you are asking, okay, do I have 6? Okay, what is the hash set is going to do now? So the hash set, you want the hash set to find number 6 for you, right? Okay, so what the hash set is going to do now? It will apply the hashing and get the result, and then go search in the hashing result. Okay, so for example, 6, what's the hashing of 6?
41.
41. Yeah. Are you sure?
Yeah.
What is 7 multiplied by 6? 42. Yeah, I need to review my 3rd grade, but I guess you are right. Okay, so for our hash set, if you send 6, it will put it in the place that's called 41. Okay, and calculating the hash value is very fast, so it can calculate the 41 extremely fast. Okay, so imagine in the future you came and you ask the hash set, okay, do I have 6? Okay, so what the hashing function is going to do here, it will calculate the hash. Okay, it will find that it's 41, and it will go right away to the place that's called 41 or equals 41, and will search for you there. Okay, so it won't need to scan the whole hash set for you. Okay, if you are searching for an item in a list, what happens? Just a list, not a hash set or something. If I told you, okay, find 6 in a list, so what are you going to do? You will see, okay, let's see the first number, second number, third. You will scan all the numbers, right? So you need to, for example, if we are in a hotel, I'm asking for someone, and this hotel is a list, you need to open the rooms one by one to find this guest. Okay, while if this hotel is a hash set, and I told you, okay, can you find Suley? Okay, so you will say, okay, let's calculate the hash of Suley. So the hash of Suley is 45. So you will go to the room 45 right away and search for Suley. If he's not in 45, then for sure he's not in this hotel. Okay, because if he's here, if he's in my hash set, then he's surely in which room? In the hash function, in the hash result of him, which is 45. And that's the big difference between list and hash sets. Hash sets are extremely fast when they want to find an item, because all what they need to do is calculate the hash, find the item. While lists, for example, they need to go to the items one by one. Okay, and that's the idea. Dictionary is the same issue and the same story, sorry. Okay, so when you add a dictionary, for example, a dictionary dot add like 9 Mike. Okay, so when you add this value, the key will be hashed, only the key. And depending on the value of the hashing, it will be placed somewhere in the dictionary. So tomorrow, if you came looking for the key number 9, the dictionary will hash it for you, and it will go directly to the place where it's supposed to store the key number 9. And it will look and tell you it's either here or not here. Okay? That's why when we were entering the items or inserting the items in a hash set or in a dictionary, we said that the order is not guaranteed. So for example, Sule came first to the hotel. We calculated his hash and he's in room number 3. Okay. Then maybe Saria came. She came later, but we calculated the hash of Saria and it resulted in room number 1. So in the hotel, Saria lives before Sule, although she came after him. But this depends on the result of her hashing function. Okay. Okay. So this is the story of hashing. So you calculate the value of hashing depending on a hashing function that someone else wrote. We don't write our own hashing functions. Okay. Usually they are written using prime numbers and those crazy math things to generate as random numbers as possible. Okay. Depending on your hashing value, you will be placed in the hash set. Okay. So for example, if we came after looking for you, we will find you right away. That's why we say that finding something in a hash set is operation, like one operation. So you need to calculate the hash and see. While finding a number in a list, okay, imagine the list is 100 items, then finding a number is 100 operations because you need to check each one of them. The worst case, the number is the last one, so you need to check all of them. And this is the beginning of our complexity course. After the break, we will talk about complexity and why some code is faster than other code, why some data structures are faster in searching or insertion. Okay, so we will talk about code complexity and code speed after the break, but this is just like a heads up. Okay, so we don't really care about the inner things about hashing. Okay, we don't really care about them in this particular program, but of course you are welcome to read more about hashing, see different styles of it, see what like theories about it. But this is the most basic idea. Okay, that when you talk about hash set, things are not placed sequentially. Okay, what structure places them sequentially? An array, a list. Okay, they place them like when I insert the number 1, then I insert the number 5 in a list. I for sure know that 5 is always behind 1, for sure. Like you won't find it somewhere else at the end. But when you are using a hash set, you really don't have no idea what's going on because depending on the hashing value, it will be placed. But so adding to a list should be virtually faster than adding to a hash set because you are not calculating any values. You are just in a list, you are just inserting behind each other. Okay, but searching is a very different story. Searching in a hash set and in a dictionary, it's much more faster than searching in an array or a list. Okay, so this is just so you know what hashing is in general. Okay, I won't require, like I won't ask you in an exam or anything about it, but it's very important to know what is hashing, why it's very fast to find stuff in a hashing structure like hash set, like dictionaries. Like in other languages, they have hash tables. Okay, they are all the same idea. Okay. Any question about hashing? Okay. You will also find that hash set is very common when we will work with Entity Framework database first. So when the code will be generated for us tomorrow, like we will use something to generate the code from a database. So you will notice that hash set is used very much. Okay. So it has its practical usages. Okay, but lists are easier to understand, easier to work with, easier to predict. Like lists will keep the order. So maybe for you, it's very important to keep the order. Okay. If you are talking about a list or a queue, okay, or a stack, so those will always keep the order of whatever you insert. Okay. But if you don't care about the order, then using a hash set is more preferred. Okay. So it really depends on what is your like what is the case you are dealing with now. Okay. So we need to talk more about code complexity, and we will also get two quick examples on like speed and like fast code versus slow code. Okay. But this will require us to actually need more than 10 minutes. So if you have any question, we can answer that, or we can go to a break. Like we can't really do anything in those 10 minutes now. We need more than them for sure. Okay, any question regarding hashing? Of course, this is just like an imaginary function. Okay, it's not like what they use. Okay, they use more complicated than that. Okay, oh yeah, there's one thing else. Now, you may ask yourself, what happens if two numbers or two items resulted in the same hashing value? Okay, so what, for example, 3 is resulting in 20, and 4 is also, for this imaginary function, is also resulting in 20. Of course, this happens, okay? Because you can't create a function that guarantees like 100% that nothing will be the same value. So what happens here, we call it a collision. Okay, so two items resulted in the same hashing result. Okay, so you imagine them as two people now. They have to live in the same room in the hotel because both of them resulted in the same value of hashing. So now Suley needs to live with Harris, for example, because both of them resulted like in the same hashing value, and now they need to go to the same room. And this is exactly what happens in the same list, in the hash set. Sorry. So in the hash set, if two numbers, or even in a dictionary, if two numbers resulted in the same value, okay, then there will be a collision and both will be placed in the same place, okay? And there will be some kind of a list, internal list, that will contain all of them, okay? Like inside what they call a bucket, okay? So now when you want to search for number 4 or number 3, you will go to the same place. And you need to search like the code, actually. The code, it will need to search a list of items because this hashing value resulted in more than one thing. Okay, so imagine a terrible hashing function that always returns the same value. Always, like whatever you send, it's like a hotel with one room. Everyone comes is being placed in the same room. So now your hash set actually turned into what?
List.
Yeah, so your hash set actually turned into a list, like everyone in the same place and behind each other. So when your hashing function is terrible enough to place everyone in the same place, you actually converted your hash set to what? To a list, and everyone is being placed behind each other in the same place. Okay, so like the worst hashing function will result in having all of them in the same place, which is actually equal to a list. Okay, now this happens like a function that will result like every few thousand numbers, 2 or 3 of them have the same hashing value. That's fine. Okay, that's not terrible. Okay, when you knock on the room to look for a number, you will see 3 numbers standing. Okay, you will see 3 values, 3 people. Okay, so you need to check this list of small, like this small list of values inside this room. Okay, but it's like 2 numbers, 3 numbers, not all of them, thousands of numbers in the same place. Okay, So you can read more about hashing, you can go more deeply in it, but this is just the basic idea, and this is what you need for now. Okay? Okay, so we'll go for a break now, and after the break, we'll talk about code complexity and the speed of code. Okay, and it will even make more sense why we're talking about hashing now. Okay, yeah, see you in an hour. Yeah, bye. Complexity and the speed of code, and how to, in a very nutshell, how to estimate the speed of a code and how to determine if this code is better than the other. Okay, of course, this is a very like advanced topic. We will just try to just scratch the surface here. It's like it has a lot to do with math. Okay, so it's not only the programming side of it, it's also the mathematics side. Who was recording? I think Bing. Okay, so Bing can record and Bruce Lee can record. Okay, and okay. So before that, I'm just trying to wait for the rest. So on Friday, okay, I was thinking of taking it a day off, but it's anyway, it's an exam day. So I have a medical appointment in the middle of the day, but I will be able to give you the exam. So on Friday, in the morning, I will give you the exam. You have the whole day to finish it. Okay. It will be 3 questions of algorithms to solve. You can cheat, so please don't. Okay. Like, especially now you're home. Like, I can't really come and see what you're doing. It's very easy to know if you wrote that code or you didn't. Okay. Like, I can know that. Okay. A code that you brought from the internet or a code that you didn't write yourself, it's very easy to be spotted. Okay. And like, I don't know, we always warn, and so many students, they keep repeating the same mistake over and over. So the exam will be the whole day, and it will have a small portion of your final grade, so 10-15%. So it won't affect if you fail or you pass. Okay, it's just for you to practice more, to see yourself, like you have a limit, you have a task to do, you have to finish it. Okay, so it's mostly more practice, more work. Okay, it's not intended to make you fail. It's not like a university exam. Most of the grade will be for the assignment that we will also take on Friday, and you will have the whole weekend and probably a day more to work on. Okay, so by the end of this week, we will finish the first course, the advanced algorithms in C#. Okay, by the end of this week. They still call it problem solving and logic, something like that, but we are trying to change the name. So by the end of this week, we will finish our course. For this course, we have an exam and an assignment. Okay, both of them are just algorithmic questions to solve. Okay, so please make sure to attend on the exam day. Now, if you have something, if there's a problem, I don't know, it's like you missed an exam in university. Okay, like you have an exam and you didn't show up for any reason. Now, it's not enough to fail you. That's the good thing. Okay, like even if you didn't do the exam, it won't be enough to just make you fail. So there's no excuse to say like my internet went off, or I'm like, I know I was sick, so I failed the course, I failed the year. Okay, this won't happen. Okay, because it had like there's always a strange excuse in the exam day, like always. Okay, and that's why we learned it shouldn't affect your passing or failing situation. Okay, so the more you practice now, the easier the assignment and the exam are going to be. Okay, like just redo the same questions and you should be fine. And also always follow the general rule that think about the question, try to solve it, and then transfer your thoughts into code. Don't start coding right away because that will make it even harder on you. Okay, so we still have 15. So we have 3 students missing, and I'm not sure if anyone is entering from two devices. Okay.
So Mohammed, we will get 2 assignments on Friday for this course. So from Monday, there will be a new course.
Yeah, Monday it will be a new course, but like sometimes we don't finish on time. So it will probably be on Friday or Monday. But I will give you the assignment anyway, so you can start working on it in the weekend. Usually when we give an assignment, there's always a weekend, so you can you have 2 days to work on it. The first thing is not an assignment, it's an exam. You need to finish in during the day. So I will give it to you in the morning, I will explain it. Okay. By the end of the day, we will set up a time. You need to send the solution to Slack.
I have a question.
Yep.
When you say assignment test, we're talking like make a program or something like
Yep.
that.
Yeah,
Okay.
it's totally programming. No multiple choice or
Okay.
or writing.
It's like
Okay.
write some program that you are going to give us.
Yep.
Oh,
Exactly.
that's it.
Yeah.
That's-
Like there's no memorizing things or
Okay,
please
okay.
explain something. Okay. Like we don't really care about the theoretical part here. Like we don't have time to like have those kind of exams. Okay. So everything we do is practical.
Okay, that's right.
Okay. So there's no papers or anything. Okay. So when it comes to the complexity of code, okay, there are like many ways to know the complexity of code, but what we care about the code in general is the uh, number of operations we are doing inside our like task or the piece of code that we are trying to calculate the complexity of it. So let's take a simple example. So let's share my screen here. Okay. So let's talk about the print hash set. Okay. So the print hash set is a function doing a task, okay? And it will take time for sure. Now I need to know or estimate like what is the time that this function will take in order to operate, okay? And that's what I mean by the complexity of the code. Complexity of the code, like how many operations, okay? And what is the time this code is taking in order to finish. So we usually measure the complexity of code by the number of operations you are doing in order to finish. So look at this code. It's doing a for loop, okay, for or for each. This is the same. It's scanning all the items from 1 to n, okay? And let's say that n is the length of the hash set. So how many operations this code is doing?
N.
Is doing n operations, right? Because it's scanning the hash set once, okay? And for each item, it's doing like an operation or two or whatever, okay? So it's doing n iterations, okay? Which what we call n operations, which what we call in terms of like the mathematical calculations, we call it on. So when I say that we have on operations, okay, that means like, for example, I have a list of 100 items. Okay, I want to find a number. Okay, so how do you find a number in a list? You need to scan the list one by one, item by item. So you may end up scanning the whole list. Of course, when we talk about complexity or the time, we always assume that we are having the worst case. Now you may tell me, okay, what if I found the number as the first number? Okay, I will do only one operation. Like once I find the number, I finish. We don't care about this case. We care only about the worst case. Okay, or what sometimes we also talk about the average case. Okay, but the worst case is what you need because it could happen. Okay, and maybe it's just happening over and over. So when you do one loop over a structure that's the length of this structure is n, then you are doing O n. Okay, and we care like 90% of the time, we care about just the loops that are inside the code. Okay, now consider n a very big number. So for example, if we said, oh, 1 million, like what if you are doing two console.write lines here? Okay, if I'm doing two operations, like I'm printing 2 times. Okay, so what is the complexity here?
Same. And
O 2n. Okay, because like you have n items, like n is the number of items in the list. Okay, now if you are doing one operation, then you are doing on, you are doing n operations. Now if you are doing 2 things for each item, okay, so suppose that the list is 100 items. Okay, so for each item you are printing 2 times. So how many operations you are doing? 200, right? Like you have 100 items. For each one, you are printing 2 times. So you are doing 200 operations of printing. Okay, that's what we call O2n. Okay, because for each number in the list, I'm doing 2 things. Okay, if you are printing like 3 times and maybe doing another calculation. So for each number, okay, for each item in the list, you are doing 4 things, like printing, then calculating the average or whatever, or no, not the average, calculating some number, then printing again. That's what we call O for n. Okay, now in terms of code complexity, all of those are equal to each other, and all of those are On. This is called like On is equal to O2n. Why? Because imagine we are talking about a billion numbers. Okay, so a billion in terms of like big numbers is equal to billion and a half to 2 billions. Okay, so we don't usually talk about the multiplications or like 2n, 3n. We consider all of those to be On because in terms of extremely big numbers, we only care about how many n's you are doing. Now, what we care about, imagine that we have code that does the following. Public static, let's say void, complex code, okay? This one takes a list of integers. Okay, let's call it list. So this one has a for loop. I is less than list.length or count I plus plus. Okay, so for each item in the list, I am doing what? I'm doing another for. So can anyone tell me what is the complexity here? Like how many operations I'm doing? Okay, let's say j equals 0, j less than list.count, and j plus plus. And here, like, we don't care about the operation inside the for unless it's a loop itself. So here, like any single operation. Okay, so as long as it's a single thing you are doing, that's fine. But if it's another loop, that's when we need to be extra careful, and that's when our calculations will change. Like printing, some calculating or anything. Okay, as long as it's not a loop itself, it's totally fine. So imagine that the length of the list is n, okay, and this n is 10. Okay, n equals 10. So how many operations we are doing here?
A square.
100.
For each n, you are doing another n. So it's n multiplied by n, so it's n squared. Okay, so that's a huge difference. So instead of 10 operations, now the complexity is O(n) squared. Okay, this is how I will say square. The star is, or not star, I think you can use this one. Okay, O(n) and the power is 2. Okay, so O(n) squared. Okay, so how many operations we are doing here? What is the square of 10?
100.
100. What if n equals 1000? What is the complexity here?
1 million.
So see the huge difference. So instead of 1000 operations, I did 1 million operations. Okay, so it's like it's a very like crazy difference between both of them. Okay, while when we say 1000, okay, 2000, that's fine, 3000, okay, but between 1000 and 1 million, that's like a very huge difference. And that's why, for example, when your friends in the previous question, they were using 2 for loops, and then Soleil said, I'm using 1 for loop. Now you may say, okay, what's the big deal? Now, it's not a big deal if our list is 10 items or 5 items, that's fine, but we always calculate the complexity for very large items. So imagine instead of 1 million, you are talking about billions. Okay, see the difference between 1 for loop and 2 for loops inside each other. Okay, and that's the huge difference in the speed between only 1 for loop and 2 for loops. Now imagine you have 3 for loops inside each other. What would be the complexity?
Trillion.
Yeah, so we are talking about trillions here. Okay, because it will be O(n) power of 3 or O(n) power of 4 if 4 loops. Okay, so that's just the basics of code complexity. For now, let's talk about loops only. So every time I have a loop going from beginning to the end, that's O(n). Now, if I have another loop, that's O(n) what? Square. If I have another loop inside. Now, what if I have this? Like here I'm printing. What is the complexity of this code?
O(n).
2n.
So I'm doing n operations. This is outside. So this one is also doing what? Also n operations. So I'm doing 2n. Okay? 2n is totally fine. 2n is equals to 1n. Okay, in terms of big numbers. So it's O(2n) equals O(n), which is a very fast and very good code. Okay? Now, see like the extremely huge difference between just being inside each other or outside each other. Although I still have 2 for loops, but instead of 1 maybe billion operation, I'm doing 1 trillion operation. Like that's an insane number of operations just because they are inside each other. Okay, so if the loops are in parallel, that's fine. They will look like 1 loop. Okay, what if I have something like this? So
That's
here where
n plus n square.
exactly, here where you split the code to multiple parts. So this part is O(n), right? This part is O(n) squared. So the complexity is the sum of them. So O(n) plus O(n) squared. Now O(n) is extremely small compared to O(n) squared. So the final result is what? Is O(n) squared. So we ignore the O(n) because compared to this 2 guys inside each other, that's extremely huge. We don't care about this for loop. Yeah. Okay. So when you have multiple parts, try to summarize them, but eventually you need to throw the insignificant part. Okay, and keep focusing. So you may say, oh, well, but it's more accurate if I said ON plus it's accurate, but like we tend to simplify the final result when we talk about complexity. Okay, because like if I told you I'm doing a billion operation, okay, like you may say, okay, another million, yeah, that won't be an issue. If you already did a billion operations, then 1 million isn't a big deal. Okay, what we care about is the 1 billion operations, the ON square that you just did. Okay, that's the significant portion. Okay, although if you want to be extremely accurate, you need to sum everything, but in terms of math, they don't care. Okay, so for now, our complex code always focuses on like if you have loops or if you don't. Okay, what if I have something like, okay, let's remove this one. And here, okay, let's have this one. Okay, what if here I have like a single if, okay, a single if is an operation, okay, if is not a loop. So you can compare it to printing, to anything. But what if I have something like if list dot contains j, then do something, okay? What is the complexity of this code?
It's like you have 2, 4.
A square?
Now you may argue that, okay, but let's just make it right. You may say, okay, but I don't have a loop. It's just a contains. It's one operation. Yeah, it's one statement, but not one operation, because contains is a function that has a for in it. Okay, so be careful when you use those ready functions like count, contains, okay, add, remove. You need to know what is the complexity of this function. For you, it appears like, oh yeah, this is one operation. Oh, that's cool. My code is, this is ON, this is ON, so my code is ON. Okay, that you may say. But what you need to realize is the contains itself, like inside the code of contains, there is a for. Okay, because how would you know if a list contains a number? How would you do that? You need to go through the whole list, which is what? Which is a for. Okay, that means you can't know if a number is contained without a for. Like here equals to writing another for. Okay, which now, what is the complexity now? Now I have 2 for loops inside each other, which is ON square.
Yeah.
Okay, so this is something I see lots of students just mistaking, like, oh, I'm just using order by. Order by is a crazy expensive function. Like ordering, like, you know, ordering like is a very big deal. It's even way more than ON. Okay, you can never order by just ON. Okay, so you will notice that some algorithms, they can't be done less than ON square. Okay, so like it can't be done. You need ON square for sure. So first, is there a question? What is ON? N is always the length of the collection you are going through. Okay, so ON is one for loop or one iteration. ON square if you have 2 inside of each other. And there is a very huge difference between ON and ON square. If you are able to solve any problem with 1 for or 2 fors outside each other, your code will be extremely fast. If you have to go inside each other 2 for loops, that's when you need to be careful. Like, is this the only solution? Can I optimize it? Can I make it faster? Because imagine when you are working on a website with millions of users and you are doing like 2 for loops inside each other, okay, like for each customer, go check all the orders in the history of the website. This may take hours, and you are consuming all the resources. Okay, it's a terrible thing to do. So you need to be very careful. Sometimes you need to split your collection. Sometimes you need to do parallel programming. Okay, there are so many ways to optimize the code, but at least to know that what I'm doing now is expensive in terms of time and resources. So I need to find something else. Now, this is when it comes. Yeah, sure. It's the same. Like if the while loop is going through like every element, like for example, if I'm talking about a list and while I didn't finish the list, so it's equals to like it equals to 4. Okay, so we usually use 4 because it's easier to understand, but for, while, repeat. Okay, if they are doing a loop on each item, they are the same story. Okay, like using a while will not save you anything. And of course, you may say, okay, what if the while finished early? That doesn't matter. We care about the worst case. Is there a case where your code may scan everything? If yes, then your complexity is the worst case. Okay. So you can't assume that my while will exit. Yeah, it may, but it may not. It may, like if you are looking for an item using a while and the item is not in the list, you need to scan the whole list. So it's all in. Okay. Okay. Now, this is what we call the complexity of time. Now, there's another complexity, which is like usually they ask you about it after, which is the complexity of the space. So suppose now, did we consume any space when we, where's the print? Okay, this is the print. So I went over the hash set and I printed. Did I consume any extra space? So this code of print doesn't require any extra space. But let's go to this function, which is all unique. So I have a list, and to know if all of them are unique, what did I create? A hash set, which is the same size of the list. So my space complexity is also ON because I had to create a copy in the same size of the list. So you have a list, you had to create something in the same size. So your space complexity is similar to the list that you sent. Okay, while in the print, like in the print, did you have to create anything? No. What is the complexity of this code? Or let's go to this one. This one is easier. What is the complexity in time? The complexity in time of this code? Yeah, just focus on the loops and see, do you have any loop inside the loop?
No, ON.
Okay, so this one only has one loop. It's going through all the elements of the list, and for each one is doing the add operation. The add operation of hash set is extremely fast, so you can consider it as O1, we call it. So if you are doing one operation, it's O1. So this one is only one for loop going one time. Does it need to go another iteration? No, it goes only one time. So this code is ON. Okay, what is the complexity in space, like the space complexity of this code? Did you have to create another thing? Like you have a list. Did you have to create another thing?
Yes.
Yes, so we created a hash set similar in size. Okay, so the space complexity is ON as well. So this code is ON in time and ON in space. Okay. Distinct items. Do you remember this one? So this one, we had more than one student who solved it, but using 2 for loops inside each other. So their complexity was O(n) squared. Now, Sulaim, I'm not sure, Sulaim, right? Give us a solution. He said, I am using only one loop. So I'm looping one time. By the end of this loop, I have the answer. So what is the complexity of this code? Just look at the code. Okay, how many loops? One loop. Do you have any operation that requires another iteration inside this for each? No, you don't. Okay, so this is O(n). But what is the complexity of the space here?
O(n).
Yeah, the complexity actually is O(n). So when we talk about the space, we care about the space because our space is limited. So imagine this list is 1 gigabyte. So you just reserved another gigabyte for the hash set and a third gigabyte actually for what? For the list. So Suley actually reserved like 2 ends of space. So if I give him, okay, here's 1 gigabyte of list, of integer list. Can you do it in your code? So unless his laptop or machine has 3 gigabytes free, he won't be able to run this code. So sometimes the code is very fast, like this one, but you are limited in space. So they will tell you, oh, we don't have, like our machine is only 1 gigabyte of RAM. So you need to find a solution, or only 2. So you need to find a solution that works with only 2 gigabytes of RAM. Okay, so it depends on like, do we have more time or do we have more space? And it's a balance. So if you have a lot of space, and you know RAMs now are cheap, okay, so you can go with this solution because it's only reserving 2 times the list, okay, 2 other lists. And also you can actually like cut the list in half if you like. This requires more coding, but you can like every time send half of the list to this function so it can operate. Okay, instead of sending like 10 gigabytes of a list in the same time, you can maybe send chunks of it. Okay, but what we care about now is just the calculation. Okay, so this one, always look how many loops. Okay, do you have any operation that is a loop also inside it? If yes, then it's a square thing. Okay, or like O(n) square, or O(n) like power 3, power 4, power 5. Okay. Otherwise, if you only have one for each going from beginning to end, okay, that that means it's only O(n).
I have
Okay,
a
now,
question.
yeah.
Sorry.
Yeah.
The else result remove part, wouldn't remove have to check the existing list? Wouldn't it add the O(n)?
Yeah, that's a very good question, actually. Well,
I mean, in list, yes.
Remove the first occurrence.
Maybe use
yeah. You know what? I think you are. I think you are right.
Yeah,
in
I
list
think
is-
about it is
Yeah.
in the list remove is also use a for.
Yeah, the remove is will search for the item first, then it will remove it. Yeah, well, actually, Surya just cheated us all. This one is also O(n) square. Okay, now maybe,
Maybe
if you
can
assume
use-
that the number will always be at the end, no.
We can use another hash set because when we move from hash set, it's
Yeah,
no
maybe
need
you
to-
can use another hash set instead of a list.
Yeah.
Yeah, if you use another hash set, yeah, probably.
But the issue is that for make the hash in write time is not consume a lot of resource.
Sorry,
because
if what?
it's not the same when you write, when you add a value in the list and you add the value in the hash set.
Yeah,
So
adding
the hash set take
maybe
more
the
time.
same. Yeah, adding the same. Like adding to a list, it will just add to the last place.
Yeah, but if you compare list and hash set, when you're adding a new value in the list, you're adding quicker than the hash set.
Yeah, but the hash set only needs to calculate the hash, which is like very fast too. So we consider them like both we call O1, like one operation. So to add to a list, you just add it. So this is O1. To add to a hash set, you calculate the hash, which is very fast, it's O1, and you add. So adding is the same. Removing the problem, this is like, looks like ON operation. Okay, so removing actually from a list, if you want to remove from a list, you need to go search for it. This is a loop, right? So it's ON. Okay, that's the problem. So unless you can use another hash set, but let's talk about remove in a hash set. Do you need a loop to remove from a hash set?
No.
Why we don't need a loop to remove from a hash set?
It's like what you said about the hashing function.
Because it will need to find the element, right? And to find an element in a hash set, you just calculate the hash, and right away you are in place. Okay, so finding things in hash set is extremely fast. Okay, it's O1, it's one operation. While finding things in a list is ON, you need to scan the whole list. Okay, that's why adding and removing and searching in a hash set is extremely fast. Okay, while in the list you can add quickly, but you can't remove quickly. And here I'm just assuming that it will add right away. So I'm assuming it's a very fast thing, but one can also check from the manual of C#. Okay, I guess you can add, like it will just add to the last place. It doesn't need a loop for sure. Yeah, it makes sense if it's O1. Okay, so thanks, Zaria. Actually, you found like, so this code actually is what is ON square. ON square in terms of time, and O2N in terms of space. Okay, and this is like 50% of the whole complexity thing. Now, this is how you calculate complexity. Just count how many operations you have and focus on the loops. Okay, this is the whole story. Now, of course, like you have more advanced math, you have more advanced things when it comes to complexity, mostly math stuff other than programming stuff. So we don't really care about them. Okay. Yeah, so let's. So what about finding the max element? So let's take this question. Find the max element in an array, okay, array in ON time. So I want to find the maximum element in an array in ON time. Can you write a code that does this thing? When I say ON, what does that mean? Like you can't have more than one loop inside the other. That's what I can mean by ON. Okay. Okay, let's try to write it.
So when you say O1, does it mean that there is no loop?
No, there's a loop, but it goes like, it goes from beginning to end once. That's it. You don't go over and over. If you are going over and over, that's more than O1. ON, sorry. Am I saying?
I'm talking about O1.
Sorry. Yeah, sorry. I think I was mistaken. If I'm saying O1, that means one operation. Which is actually it's impossible to find the max element in one operation. Okay. Sorry, I meant to say ON. So ON means you go one for loop. Okay. O1 is like searching in a hash set, searching in a dictionary. That's O1. Okay. That's like in one operation you can finish. Okay. Now, obviously, finding the max element in an array is impossible to do in O1. Like you can't just find it. You need to scan the whole array to find the max element, right? That's why finding the max element in a random array is definitely ON. Okay. There's no way but to scan all the elements one by one. Okay. Okay, let's write this code, and I want you to just thing. So what's the difference between question 1 and question 2? Like if I told you, okay, it's not a normal array, it's an ordered array. Can you find the max element? Now you can use the same code you will write here. That's fine. But whenever you get like a special case or whenever you get more information, you need to use those information to make your code faster. So how do you find the max element in an ordered array?
Well, the first thing that we need to do is view the order of the array. Is ascending or descending?
Yeah. Okay. Let's say
take the last one.
In an ascending.
The last one value.
Ascending. I'm not sure how that's you write it. Okay. Anyway.
There is a C after. Yeah.
This. Oh yeah.
I think so.
Yeah. So let's say it's ascending.
The last one value.
Okay. So as we said, like it's ascending, like 1, 6, 12, 20. So if you want the max element, what should you do? Just code the last one. Okay. So now what is the complexity of this code?
O1.
All what you need is one operation and that's it. Okay. And that's like the difference. Now you may say, okay, this code works. Yeah, but this code is for any array, it's ON. So I can write a code that is extremely fast for like a special case, which is the ordered array, ascending order. Okay. Yeah, let's try to find the first one. We actually wrote that code before. So it's not like something new. Wow. It's funny how much code we write by the end of the day. Okay, so if we say public static find max in array. Okay, sorry, let's need to return an integer. Okay, just the max. And it takes an integer array. Okay, so I'm saying I don't want to go more than once. Okay, so I need in one scan to have my result. So we can say, as we said before, that this is the result and it equals to the first item because my first item is the highest so far. Okay, I want, this is all what I know. I just can see the first item first. Okay, so what should I do now? For int I equals, we can start from the next item. I less than array dot length I plus plus. Okay, so here I have one if condition. So if the item I am seeing now is bigger than what, if the item I'm seeing now is bigger than the result, then the result should become what? This item, because it's bigger than it. Okay. Okay, by the end of this for, I should return what? I should have my result. So look at it, like we went through this before, okay, like the same code. Now, what is the complexity in terms of time? On, right? Because it's only one loop through the array one time. By the end of this loop, I have my result. What is the complexity of space here? How much did you reserve to find the solution? You reserved only one variable, so you can say that it's O1, the space, which is extremely low and totally fine. So I didn't have to reserve another array or another hash set or whatever. I found it in O1 very fast and in like almost no space. Okay. Now, if it's ordered, that would be even better. Okay. If it's ordered, that's where I can I can just go and find the last or the first one, depending on is it ascending or descending. Now I have a more interesting question. Okay. This one requires more work. Okay. So I want to find the number with the highest frequency in a list of integers in ON. So this is a list of integers. Okay, let's take this one. Okay, this is a list of integers. Let's say also 5. What is the number with highest frequency? What is the number that appeared the most?
5.
It's 5. Okay, because 5 appeared 3 times, right? So the result of this array is, or this list is what? Is 5. Now, if I told you it's okay to do it in ON square, then the solution will be very easy, right? What should you do? Take each number, okay, each number, and make another 4 to count how many times this number appeared. So you will count, okay, 5. Let's do another 4 for 5, and you will count. Then 6, okay, let's count. 2, okay, let's count. Okay, so each time in the outer 4, you are doing another 4. So what is the complexity here? That's ON squared. Okay, because you are using 2 4s, and it will be very easy to solve it with 2 4s. Now the challenge is to be able to solve it in O1. So in 1 4 or 2 4s, but outside each other. Like you can use as many 4s as you can. Of course, not like endless, but like 2 4s, 3 4s, it's okay. But if they are outside each other. Okay, so that's a question I need you to think about. Okay, and I also want you to find a number in an ordered list in less than ON. Okay, so you have a list of numbers, obviously. So if I told you find a number, what would you do? Just you will go one, of course, don't use contains, okay? Like contains is ON. But you will go and search the numbers one by one, right? So what is the complexity of this code? It's ON, right? Because you will search the whole array or the whole list for this number. But I'm telling you this array or this list is ordered. So can you take advantage of this one and find the numbers in less than ON? What would you do if I told you that the order, the list is ordered? Now imagine yourself like as a person working with a big ordered list. And I told you, okay, find if there's 11. So what would you do? Would you scan the whole thing or what?
Compare the middle number.
Yeah. So let's just spoil the answer. Okay. So let's change into code. So let's saying, okay, look at the middle of the array. So the middle of the array is 20. So if there is 11, where should it be? In the left side or the right side? Yeah, we are talking about ascending here. So if the middle number is 20, then if you are looking for 11, then 11 is for sure where?
The left.
In the left part. It for sure it's not in the right part, because if the middle is 20, then everything behind 20 is bigger than 20. So 11 will not be here, right? Now, do this thing over and over until you find a number. And eventually you will find log n. It's not on. Log n is way faster than on. Log is the logarithmic function. When you cut your space in half every time, this is called logarithm of n. Okay, but it will be like, the idea is that you will not scan every single item. Okay, so take advantage of the hint that Suley gave us, that always look at the middle and then search. Then look at the next middle and then search until you squeeze the space until you find the number. Okay, so those are 2 questions for today. You can have some fun. Okay, now the lab should be about something very similar, about dictionaries probably. Okay, so you get to practice dictionaries again. Okay, now before we give you a lab on hash sets and stuff, I really want you to go redo the same things, try, because each one is different way of thinking. Hash set is different way of thinking than dictionary, than a list. Okay, each one of them is suitable for different cases. The more you practice, the better you become. Okay, so that was our introduction to code complexity. Okay, first, any question?
I just want to be clear. So the second one, find the number in ordered list in less than on, means use no loop.
No, there could be a loop, but this loop is not scanning everything. Like this loop, like here you need
Does
to use
not
a
scan
while.
everything. Oh,
Yeah.
okay, okay.
Yeah, so here you are not using a for, you think about a while.
Okay.
Okay, think about whiles and use it here. Okay, don't go with for.
And
Okay.
Mohammed, will we be doing other generic collection as well after that hash?
We will talk, yes, about 2D arrays, so arrays of 2 dimensions.
Oh, multi-dimensional.
Yeah, and we will talk about stacks and queues, but in a very like simple way.
Oh, and these are like non-generic collection, queues, stacks.
No, yeah, there is a generic stack and a generic queue that you can put anything in them. Hash set also. Okay, you can create a stack of anything, any type. Okay, but by the end of this week, we will stop learning and about data structures, and then we'll move to classes and objects and all this stuff. Okay, so those questions or this data structure are extremely common when you go interview for any company, especially the big ones. Like, don't think that it's impossible for you to work for Amazon. Like, maybe not now, but after you get experience of 1-2 years, you can start interviewing there. And this is what they are going to ask you about. It's a very tough interview. I tried a few years ago and I didn't pass. Like, I passed half of it. But then I went without preparation. That's the problem. Like, I thought, yeah, they will ask algorithms and okay, that's fine. But you really need to prepare. And what you need to prepare is exactly those things. Like hash sets, dictionaries, complicated array questions, calculating the complexity. And there is something called recursion, which is extremely hideous and horrible, but they ask so many recursions and trees. I'm not sure if you know trees. So, but they won't ask you like, how do we create a website, or let's create a website, or they will just see how do you think for the most part. Now, maybe at the very end, they start asking you about specific language thing, but they will tell you, you can write in any language, C#, C++, Python, like we don't care. We just want to see like, can you think? Because if you can think logically, then the syntax is a matter of a week and you can learn it. Okay, they don't care if you memorize every function in C# because they don't even work in C#. Okay, and maybe they will put you in a team that uses like a very different language that you never see. They don't care. They will give you the time to learn. Okay, but they need to know, like, do this guy know about for example, the speed of code, or this person only can write like crappy, extremely slow code. It works, but it's extremely slow, which is not good for a big company. Okay, Google the same story, Facebook the same story. Like you may have a PhD in IT, and this is the interview they will be doing for you, which is very irritating for many people. Like I have a master's degree or a PhD, and they are asking me about trees and hash sets. Okay, but this is their, like, it's working for them eventually. Like obviously it's resulting in hiring the best people. Okay, and it's not like a very like hard thing to learn. In few months of preparations, okay, while you are working in another company, you can prepare for this kind of um, interview. Now there's a book, like we have a minute here. It's called Cracking the Code Interview. Yeah, this is a very famous book that people use to prepare for this kind of interviews. Like if you ever want to interview for a company and you know that that's what they ask, Cracking the Code Interview is full with hundreds of algorithmic questions with their solutions, and they will tell you a ton of advices, what to do, how to talk, how to prepare, like everything you need to know about the interview. And it's like a standard book somehow when it comes to preparing for interviews. Okay, so keep this in mind. Like you don't, of course, like many questions that we are solving, actually I brought the ideas from this book. Okay, like, and you will notice that many questions that you know already, or it's almost similar to what I know. So you're almost halfway through. Okay.
But I think that is written in Java, I think, this book.
Yeah, but Java is very similar to C#, and you don't really care about copy pasting the solution. You just want to see the idea.
Right. Okay.
Yeah, it's written in Java. Yeah, but it's like we are lucky because Java is very similar to C#. But of course, you shouldn't be reading the answers or copy pasting them. Okay. Once you read the idea, that you can implement it in any language, but you need to try to solve them yourself first. And it's good to practice now, like prepare yourself, like even a year before, 2 years before. Like what's the, like if you doing an algorithmic puzzle every week or two just to train your mind. It's just, you can do it for fun. Okay, every week or two, grab like a question and try to think about it. Okay, another place where yeah, this guy, I guess, no, not this one. Yeah, you will find like a ton of people on Facebook doing explanations of not Facebook, sorry, on YouTube, doing explanations of a real life example of questions. Okay, ask in Google, ask in Facebook, Amazon. They will tell you what is the question, they will solve it for you. They will tell you, like, first they start with a simple question like, okay, can you find a number in an array? Okay, so you will find it in ON. Okay, that's nice. Then they'll tell you, okay, but this array now is ordered. What are you going to do? Are you going to change your code, or like, can you come up with a better idea? So that's how they go gradually. Then they will tell you, oh, but this array is actually bigger than our memory. This array is like 10 gigabytes and we have only one. What should we do? Okay, so they go from a very simple question to more complicated scenarios. And those guys on YouTube, they will show you exactly what they ask. And actually, the questions are real questions from real interviews. Okay. Last thing I want to show you here is Glassdoor. So Glassdoor is a very famous website. You can search any company. So suppose that you are, for example, interviewing for Ubisoft. So just write Glassdoor Ubisoft, and then you will see everything you need to know about Ubisoft. For example, what is the review of people working there like? Is it a terrible place? Is it a place that respects your work-life balance? Okay, what stuff you get there? Like, do they have free gym? Do they have free coffee machine? I worked for a while in a company. They had a free beer machine. Like, it was like the best thing for many people. I don't drink beer, so I didn't get to enjoy it. But some people, they said like, we work here because they have this machine. So you will see very strange things here and there. You can see photos from the company. It gives you a feeling. Of course, this is not their life. Like, most of their days are just miserable writing code, but this is like things they do every like few months. What we care about, yeah, also you can see salaries. This is very important because they will ask you, what do you expect here? So you don't really need to ask about something. Oh, you need to sign in. You don't need to ask for a number that's very low or very high to their average. So here you can see the average of, yeah, someone with 1 year of experience, this is their average. So, for example, you will find that companies like Google, Amazon, their salaries are much higher. But of course, the work is much harder in most cases. Interviews, this is what I want to show you here. So, oh God. Why it wasn't like this? I don't remember. It was this. Okay, so I don't want to look in now. But if you went here, you will see the whole story of interviews from other people. They will tell you they called me first, then they asked me this question, then I went there, then okay. They will tell you the whole story. They will tell you what questions they were asked. So you get a very good idea what to expect, what is this place look like, what kind of questions. Of course, someone will tell you that they ask me those hard questions, but you need to notice that this guy is interviewing for a senior position, not for example, a junior. Okay, so be careful what you're reading. Okay, like if you saw someone saying that they were asking about, I don't know, the attitude of people or things. This is an HR interview. Okay, so don't go, like, try to find the software developers one. Okay. So people will tell you, especially developers, like, we are very lucky. Like, if you are a civil engineer, it's very hard to find interviews for civil engineers. Like, very few people write about this experience. But software developers, like, you can find thousands, especially if the company is known. Like maybe 2-3 interviews should be enough for you to know exactly what you are expecting, what is look like. But as a software developer, you will see everything. So Glassdoor is very good. And of course, you can find jobs actually. Okay, but I prefer LinkedIn for jobs. Most of the time, you will see the same jobs here and there. Okay, but like the interviews, the salaries, okay, this is something you can't find in LinkedIn so far, I guess. Benefits. So they will tell you, like, they have those retirement plans, they have free parking, maybe. Okay, they have a daycare. Yeah, many things are important for people. Some people, they need a daycare to work in a place. Okay, like they can't leave their kids home, and so you will see everything, especially for big companies. Keep this website in mind. And sometimes honestly, I just go to read just for fun. Like, see, okay, let's see what companies in Winnipeg. Let's see which one has a good review. So you will get an idea about good companies in your city, about what is the average salary, what is the average benefits package. Okay, like I like sometimes to come and read just to waste time here. Okay, but it's an enjoyable read anyways. And Cracking the Code interview, also the book you need to prepare for an interview. Okay. Yeah, of course, those are not part of the program. Those are just like, yeah, it's for you to know. Okay, any question?
Sorry, I got one more. Extending on Yushin's question before, you said, okay, so on less than on, you could use while loop to condition.
Well, no, I mean you can use while loop, but of course there should be like a trick to you need to write something to
Yeah.
shrink the space, like, or shrink the list. So like when Soleil said I need to walk to look in or to the middle of the array, that means he just threw half of it in the garbage. Okay,
Right.
he will not look. So it doesn't matter if you are using while or for, if you are going from beginning to end. Like going from beginning to end, yeah, while or for, that's the same thing. But
Okay.
I mean,
okay,
for
got
this
it.
question, it's easier to solve it with a while. You can solve it with for, but
Okay.
it's easier to solve it with a while, maybe. Okay, maybe it's easier for me. Try it with the for. I really don't know. Okay, but even with for, if every time you are going to half the array, half, okay, that's also good. That's not on. That's less than on. Okay, so what matters is the end and start of the loop, not the loop itself.
So if while is endlessly asking for an infinite iteration until the condition is met, it is still on, not
Yeah,
like
right. Yeah, because this condition maybe will be met at the end of the array.
okay.
Okay, so the type of the loop is not important. What's important is the start index, the end index. Okay. Yeah, actually, it's not maybe different for this particular question. It's not very different between for and while. Yeah, it can be done with for. Yeah, like both of them, I guess, the same thing. Okay, but you need to know where to start, where to stop. That's the whole story. Okay, and think about cutting the list in half every time. Okay, so I leave you with those questions and with the lab. Okay, I really hope that you attend the lab and get the most of it. Okay, and if you have any questions or suggestions, we're always available on Slack. Okay, yeah, see you tomorrow, guys. Yeah, bye.